Alright, let us take another example that says a rectangular solid, it's like a box, okay, with square base, has a surface area 541.5 centimeter square. Find the dimension that will result in a solid with maximum volume. So what we're putting is, we're putting that box in a sleeping position, meaning that the longer face is on the bottom. But this is what it is talking about. If you make this upright position, that this will be the base, right? What it says is the base is the square position. So I'm assuming that, so square means all the sides are equal, right? I'm assuming that the dimension of the base is x, meaning the length of base equals to x, and then let's say the height of the box is, let's say, y, right? So what you want to do is you want to maximize the volume. Can you tell me what is the volume formula? Volume is base area times the height. So what is the area of the base? Area of this one is x times x square, and the height is y, right? So the volume will be x squared times y. But you want to maximize it. To maximize it, you must have either only x or only y on the right hand side, right? But how do I replace y values? Well, let's use that. What it says is the surface area is 541.5. What do you mean by the surface area? Surface area is, what is the formula for the surface area? Surface area is basically the sum of the area of all the faces, right? So what is the area of this face is x squared, and area of that face on the other side, opposite of that, is basically x squared, right? So that will give you x squared plus x squared plus, now let's find out the area of the sides here. What is the area of this face? It is like y, and then this is like x, right? X times y. So this is x times y, the opposite of x times y, the top is x times y, the bottom is x times y. So it will be basically 4xy. If you simplify this, you will get 2x squared plus 4xy, right? That's the surface area. But what is the surface area given? It is 541.5, right? So you will get 541.5 equals to 2x squared plus 4xy. I want to solve this for y, and I want to use this on the volume. Okay, what you get is, so let's subtract 2x squared. You will get 541.5 minus 2x squared equals to 4xy, right? Now divide by 4x, you will be solving for y. So what you get is 541.5 minus 2x squared over 4x equals to y. If you want to, it will be easier to simplify, like you split the denominator. What you get is y is 541.5 over 4x minus 2x squared over 4x equals to y. So if you simplify this, you will get y equals to 135.375 minus this is x, right? So x over x minus 1 over 2x. That's what you get, right? Okay, so now we want to plug in this into the v, hence so v equals to x squared times y is 135 minus 0.375 over x minus 1/2 x, right? So what you get, if you distribute this x squared, you will get 135.375 and then x, because x squared divided by x, right? That will be x minus 1/2, and that will be x to the third. Okay, now to find out the maximum or minimum value of v, or maximize or minimize the v, the process is same. Find out v prime. What is v prime? Is 135.375 minus 3/2 x square. That's what you get, right? That is the v prime. But to find out the maximum or minimum values, you set that equals to 0. So what you get is basically you get 135.375 equals to 3/2 x square. You multiply both sides by 2 and divide by 3. So what you get is you will get x square equals to, so x square equals to, you get 90.25. 90.25. So what will be the x value then? If you take the square root of on both sides, then you will get x equals to, basically we are taking the positive square root because it cannot be negative, 9.5. That's what you get. So x is 9.5, right? Both x's are 9.5. Now I want to find out y. What is the value of y? You plug in x here. If you plug in x, then you will get y, the length will be 135.375 over 9.5. 9.5 minus 1/2 times 9.5. That's what you get, right? So if you do that, you will get basically y is 9.5 as well. If you use calculator for that, you will get y is also 9.5. Now what you want to do next is you want to verify that these x and y values, basically they maximize v, right? So to check whether it is maximum or minimum, you find out the v double prime. So what is your v double prime? Is that will be, we want to find the derivative of v prime, right? So this will be 0 and this will be negative 3/2 times 2x, right? So it will be negative 3/2 times the 2x. If you cancel that, you will get negative 3x, right? So at x equals to 9.5, v double prime equals to negative 3 times 9.5. If you use calculator, you will get negative 28.5, right? Which is negative, hence v has maximum at x equals to 9.5, which is the end of the solution. All right.